Hey, good afternoon, sixth graders. It's Mrs. Nelson, and today our learning goal is to be able to describe the conservation of mass. We will get into what that means and how we can prove that the law of conservation of mass is in fact true. But before we do, I want you to start thinking about this question. Okay, when we build new buildings, okay, whatever it is, a skyscraper, a school, a library, does the total mass of the earth decrease, increase, or stay the same? So when we're putting new buildings on our earth, what does that do to the mass of our earth? Does it decrease, increase, or stay the same? Okay. I'm going to have you guys think about that while I show this video. It's just a minute long, but it's going to show you a time lapse of a building being built. It was built from start to finish in 15 days, and it's pretty fun to watch. So just keep thinking to yourself, how is the Earth's mass changing when this building is being built? All right, I'm going to pause that there, and I'd like to show that video because it kind of shows you what happens in production of materials and how it's brought to the job site. And in 15 days, they created that building, which looks like it was a hotel. So, okay, be thinking about that. We're not going to answer that question yet. When we build new buildings, does the total mass of the earth decrease, increase, or stay the same? Be thinking about that. The law of conservation of mass states this, okay, and you want to pause the video, teachers, and have your students write this down in their science notebooks. This is one that they would definitely want to remember, okay? The law of conservation of mass states that mass is neither created nor destroyed by chemical reactions or physical transformations. Mass is neither created nor destroyed. Okay, let's go a little bit deeper into this and see if we can't find some real life examples. Let's look at a campfire, for example. If you build a campfire like this one, you start out with a big pile of logs, right? And as the fire burns, the pile of logs slowly shrinks. And by the end of the evening, all that's left is a small pile of ashes. Well, what happened to the matter that you started with? Was it destroyed by the fire? Well, mass can neither be created nor destroyed. So I'm thinking no, but then what happened to it? Well, let's look at this. When we start a fire, we start with the logs and the oxygen required to start the fire, right? And in the end, what the gases that come from those logs being burnt are carbon dioxide and water vapor and ashes, right? So does that mean that the mass was destroyed or not? Well, let's look at this equation. So we can think of it like this, okay? The mass of the wood and the oxygen is the same as or equal to, it yields the ashes, the carbon dioxide gas, and the water vapor that happen as a result of the wood burning. They're equal, right? So it's changed state, but if we were to look at the total mass of the ashes and the carbon dioxide gas and the water vapor that came as a result from burning that wood, we would find out that the wood and the oxygen are equal to the amount of mass that is in the ashes and the carbon dioxide gas and the water vapor that happens while burning. Okay. All right, guys. Now I want to show you a couple examples that kind of prove this theory or this law to be correct. Okay. So I'm going to click and enjoy. All right, guys, let's go back to my presentation here, and I hope that helped you understand the physical transformation and the chemical reaction, how no matter or no mass was created nor destroyed. Okay. All right, you guys, so now I have 3 questions here, and this is what I'm hoping is that you can have some discussion with your classmates about these 3 talking points, okay? So the first one, why did the mass of the paper remain the same after it was torn apart? So you can pause, teachers, and just talk with your class about that question there. When you're finished talking about that, I want you to talk about this question. Why was the mass of the vinegar, balloon, baking soda, and the bottle the same before the reaction as it was after? So when that air was still in the balloon, why was it the same as it was before the reaction happened? And the very final question that I would like you to discuss is, why did the mass change when the balloon was removed? All right, guys. I hope you had a chance to talk with your classmates about those 3 questions. Now I want you to think about that time-lapse video of the building being built. Do you think that the mass of the Earth changes? Does it increase, decrease, or stay the same when a building or even a city is built? Has your answer changed? Remember the law of conservation of mass. The law of conservation of mass states that mass in a closed system is neither created nor destroyed by chemical reactions or physical transformation. It is conserved. All right, you guys, my time is about up. I hope you generated some good discussion, and make sure to get this law of conservation of mass written down in your science notebooks. All right, have a great day. Thank you. Bye.